Hey, welcome back, and here are our examples of how to draw Lewis dot diagrams. So we're going to start here with the example of F2, fluorine. So fluorine is never found just on its own in nature. It's always bonded to another fluorine. We call it a diatomic molecule. We don't need to know that right at this moment. But what we do need to figure out is how many valence electrons there are. So looking at step 1, determine the total number of valence electrons. Remember, look at your periodic table to figure that out. Since fluorine is a group 7A element, it has 7 valence electrons. And remember, E- is an abbreviation for electrons. So 7 valence electrons for that fluorine there, but we have 2 of them. And since we have 2 fluorines, that means we have a total of 14 valence electrons. And that's the number that we're going to use to make sure that we've shown where all the electrons live, to make sure that we're getting the right number of that we're filling the octets on all of the atoms, and to make sure that we don't need to add double or triple bonds. I gave you a spoiler in the last video. Fluorine is single bonded, but we're going to see that here in this example. So the next step, step 2, we want to put the least electronegative atom in the center. Well, here we only have 2 atoms. So if we only have 2 atoms, they're just going to be bonded in a line. We have our F and we have our F. So step 3, use pairs of electrons to form bonds between all atoms. So I want to bond this fluorine and the fluorine. I'm going to use a pair of electrons between the two to show that they're bonded. I could have also written this like this: F, F, with a line in between them, and that line also shows that there's two electrons in that bond. It's a single bond. It takes 2 electrons. Okay, so that's step 3. We've bonded all the atoms. Now we need to use the remaining electrons to complete octets around each atom. So we started with 14 electrons. I've already used 2 of them. And so the next step, we need to figure out where the other 12 electrons go. And so the other thing that we want to keep in mind is that each of these fluorine atoms, they want to have 8 electrons around them. And so right now, each of them has 2. They're sharing 2 with each other, and so that counts as this fluorine currently has 2. It wants 6 more. This fluorine has 2. It wants 6 more. And so we start by dotting around. And so that's 6. That's another 6, and we can count just to double check, because we always should. 2, 4, 6, 8, 10, 12, 14. That's our 14 valence electrons, and so we check each fluorine. This fluorine has 8, so a full octet, and this one has 1, 2, 3, 4, 5, 6, 7, 8, so a full octet as well. And so what this shows is that fluorine is always going to have a single bond between the 2 fluorine atoms, and each fluorine is going to have 6 electrons that just belong to it, and it's sharing 2 electrons with the other atom. And that's the Lewis dot diagram for fluorine. Moving on to the next one, methane. This is CH4. So determine the total number of valence electrons. Carbon has 4 valence electrons, and hydrogen has 1 valence electron each. So 4 plus 1, 2, 3, 4, it's a total of 8 valence electrons. We put the least electronegative atom in the center. You can use p-table or some other electronegativity chart to help you figure out the relative electronegativities of all of these atoms. But our other rule is that hydrogen can't go in the center. And so since we only have carbon and hydrogen in this atom, or in this molecule, that means the carbon is going to go in the middle. So we have carbon, and we have hydrogens all around it. If possible, we like to use 90-degree angles. It just makes our diagrams look neater, makes it easier to read. Even if the geometry of the molecule is not 90 degrees, we use 90 degrees in our Lewis dot diagrams typically. Okay, so we've placed the atoms, we figured out how many valence electrons there are, and so now I'm going to bond each hydrogen to the carbon in the middle with 2 electrons. And so each bond here has 2 electrons. I could have also drawn this like this. And this is how you will really see it. We usually represent bonds with lines. But when we're first learning it, it's sometimes hard to remember to count a bond like this as 2 electrons, because that's what it is. It's worth 2 electrons. And so now we want to count. We want to see how many electrons we have left. We started with 8. We've done 1, 2, 3, 4, 5, 6, 7, 8. Oh, wait. That's it. Let's check our octets. So hydrogen always wants 2, and each hydrogen is sharing 2 electrons with the carbon in the center. And now the carbon in the center, it has 8 electrons, so it has a full octet. And that is the Lewis dot diagram for methane. We're getting an invader. Go away, cat. Seriously, away. Thank you. Okay. Flipping to some more examples. N2. So N2, I already said as a spoiler, that one has a triple bond, but here's where you're going to learn how you would have known that it's a triple bond. So first step, determine the total number of valence electrons. Each nitrogen has 5 valence electrons, so a total of 10. 10 valence electrons. And so they're both the same. There's only 2 of them, so N, N right next to each other. And we start by connecting them with a single bond. So 1 bond in between each other. That's some of the electrons. And now, okay, so we started with 10. We've used 2 of them so far. That means we have 8 left to split between these nitrogens. And so, all right, well, I'm going to grab a pencil because I might actually end up erasing on this one. So I put 1 around one of the nitrogens, 1 around the other. I'm keeping track, so that's 4, 5, 6, 7, 8, 9, 10. And so I've used all of my electrons. Let's check. This nitrogen here has 1, 2, 3, 4, 5, 6 electrons. This one has 1, 2, 3, 4, 5, 6. But they want 8, and so that doesn't work right. We don't have full octets, and so if you run out of electrons before you're able to fill the octets, that's where we introduce multiple bonds. And I had to try that. I mean, I could have done some brainstorming on it, done some planning, but if I was just tackling this problem, I would start with a pencil and eraser. So now I'm going to try that again. I'm going to add a double bond instead. So I'm going to add another bond to see if that solves my electron problem. So I started with 10. I've now used 4 of them. I have 6 left. So if I split them, that's 3 on each. And we see, so now this nitrogen has 7 electrons, and this nitrogen also has 7 electrons. It wants 8 electrons. So we're still not done. I'm going to add another bond, a triple bond. Quadruple bonds don't exist, by the way. So now triple bond, that triple bond is using 6 electrons, and so that means we have 4 left. 1, 2, 3, 4. We check our octet. This nitrogen has 1, 2, 3, 4, 5, 6, 7, 8 electrons. This one also has 8. And so we've got full octets. And so that's the molecule. And if I draw that using bond lines instead of dots, it looks like this. pair up your electrons, please. So notice how up here I had the electrons separated. When they're actually around the molecule, they're going to pair up. And so we have what's called a lone electron pair. So draw the electrons together. I'm going to pause there and cut the video short so that these videos aren't huge. 2 or 3 more examples in the next video.